o'clock. Since we're a small group, we do invite questions. We do invite questions, throughout the presentation. It shouldn't throw us off our time too much. And we'll also have a question period at the end of each section. And you could also use the chat if you need any technical assistance or if you have any questions. I don't think I need to tell you where the bathroom is. You should probably know where your own bathroom is. So if you need to, if nature calls, we completely understand. Okay. So our safety moment. So unfortunately, we are still in a pandemic. And I'm sure you know all these, but just a quick reminder, refresher on these things. At the construction site, some tips to ensure you're adopting health and safety rather during pandemic. If you're feeling off, you're feeling ill, definitely stop, go home. Frequently wash your hands. Stay 2 meters from others whenever possible. Don't touch your eyes, nose, and mouth. Make sure you're wearing personal protective equipment, especially if you have to work within 2 meters of others, and ensure the site has 2 meter separation from public. And lastly, stagger your breaks to limit the gatherings. Okay. So a quick intro on CIMA. I'm sure you guys know who we are. We're a multidisciplinary engineering firm in infrastructure, transportation, buildings, and of course, energy, electricity generation, transmission, distribution. We're a Canadian firm based in Quebec, established over 30 years ago. We have 2,500 employees and still growing across 30 offices. And we're growing every year. We're growing our services as we grow our firm. Cybersecurity is, as it applies to critical infrastructure networks, is another service that we are adding to our portfolio of services. So I will now pass the baton on to Doug, who is going to talk about RHEA and get into our cybersecurity fundamentals.
Thanks, Tim.
No problem.
You can pass to the next slide, though. Yeah, so thank you, everyone, for your participation and interest today. As Tim introduced, I'm Douglas Wiemer. I'm the Chief Technology Officer specifically for cyber for the RHEA Group. RHEA Group as a whole is a full-service system solutions and security engineering company that has a predominant market towards the critical infrastructures and utilities, and that applies across multiple different critical infrastructures, including transportation, space, traditional utilities like energy, and so forth. And so we provide security engineering services, as it indicates here, which includes governance, physical, and cybersecurity activities. And what we're presenting today is a very small, specific subset of the total cybersecurity capabilities that we have, but hopefully that's interesting for you. We provide professional engineering services as well, which includes experts for your various engineering programs. Concurrent design engineering, which is really a optimized process for bringing different technical disciplines together and to solve complex engineering problems and projects in an optimized way. And so we have a series of tools and processes to be able to help with that. We are involved in aviation, and so that has to do particularly with aircraft ground icing and de-icing solutions. And we also have quite a considerable background in space, which includes solutions and services capability for Earth observation and global solutions towards global environmental challenges, as well as ground systems engineering, which includes delivery of, for example, mission control systems for commercial satellite constellations and so forth. We are currently, I think we're probably well over 750 employees, and so we're certainly over 700 employees as shown on the slide, and we're present in 11 countries, and so those are predominantly in Europe, and then as well our 2 offices that we have here in Canada, one being in Montreal and the other being in Gatineau. Next slide. So yeah, what the next section of the presentation is going to present some information about a cyber range and should answer this question: what is a cyber range? And not only what is a cyber range, but what can a cyber range be used for? And then later in the presentation, after the demonstration, we'll touch on how that cyber range can be used to support the activities that are necessary for your NERC-CIP compliance. Again, that discussion that we had at the beginning of the call touched on, well, what's your motivation for being here? And in a few of the cases, there was a very general interest in cybersecurity as a whole. And so this presentation looks at cybersecurity and how cybersecurity, how to achieve some cybersecurity compliance, how a cyber range specifically as a tool, a cybersecurity tool, can support that. But as far as the broader needs for cybersecurity in terms of protection and operation services and so forth, that's probably a topic for another day. And certainly if there's interest in going into more details around other cybersecurity aspects, then we can certainly arrange other calls and other demonstrations and other discussions. Next slide. So what is a cyber range? This is a very specific definition. This comes from documentation. It comes from the National Initiative for Cybersecurity Education, and it identifies that a cyber range is an interactive simulated representation of an organization's local network, system, tools, applications connected to a simulated internet level environment, provides a safe legal environment to gain hands-on cyber skills, and a secure environment for product development and security posture testing. And so basically what that's saying, the way that I like to summarize these very kind of verbose definitions, is that a cyber range provides a safe environment in order to do dangerous things. And so if you think, for example, that we want to be able to do security posture testing of our operational systems, and we may need to do penetration tests, and those penetration tests may, for example, involve malicious code or different types of attacks. That can be dangerous to do against operational systems because those operational systems are live. And of course, we don't want to impact the direct operational capability by what might happen as a result of the kinds of testing that we do, or the kinds of malware we may introduce, and so forth. And so in the same way that a rifle range, for example, is a safe place in which you can test and use and learn to use a rifle, a cyber range creates a safe environment in which you can basically do the same thing at a very technical level with your information technology systems and operations technology systems. And so you can emulate, replicate, simulate, and we'll talk about some of those different terms in the next slide, but you can create this representation of your operational systems, and in that new representation, that safe place, you can run dangerous malware, you can do dangerous attacks against them in an environment that's not going to then affect your operational systems. And as Tim mentioned, if you have any questions as I go through this, please don't hesitate to stop me along the way. Next slide. So this difference between simulation and emulation, and this is an important distinction for a pre-production test environment. A simulation often uses, let's say, a model of an environment, but that model may in fact be a piece of software that is not actually the real operational software, but instead is a representation of the operational characteristics of that software. And so it may produce certain outputs and receive certain inputs, but it's not actually the operational software. And it can be used for a lot of different aspects of testing, and that's great. But when it comes to something like a penetration test, where you want to know how your real systems are going to respond to that penetration test, it isn't sufficient. And so then we move to an emulation. And so an emulation is the act of replicating or virtualizing in a different system exactly how the original system works internally, and I would say even using the exact representation of the applications or systems that are in your operational networks. And so from that perspective, we can leverage on the virtualization technologies that are available today. We can take a virtual machine image of, let's say, a control system, run that virtual machine image within the cyber range, and do various testing against it in the cyber range. Cyber range goes beyond just having let's say, an external non-production version of your mission control or your control system running in a virtual machine, but in fact allows you to create interconnected scenarios of your end-to-end systems view within that emulation environment. And so it's not just the control system, but controlled devices and enterprise networks and firewalls and switches and so forth. And so you create in this virtual environment a near real replication of your operational systems as with as high a fidelity as possible. So as close as possible to representing the operational systems. You recreate that in the cyber range, and that allows you to get much more accurate representation of how the real systems are going to respond to things like a penetration test. Our next generation cyber range service are powered by our CITEF application. And so this allows assets emulation automation within it for as realistic as we possibly can in this virtual environment, and recognizing as well that some SCADA systems and other industrial control systems may not be able to be replicated. We also allow the interconnection to real physical hardware systems while still remaining in that virtual environment. Next slide, please. So why would you use a cyber range? And from a market perspective, if you look at the cyber ranges that are available on the market, and there are a number of different companies that produce a cyber range, the dominant use of a cyber range is in training. And so these are very often using, let's say, packaged or prepackaged scenarios that are representative of the types of scenarios that your operators or your security operations staff or even your system operators may come against, but they're not necessarily using the actual representation of the systems that are in your environment. And so they're prepackaged scenarios. They represent a wide scale of use cases, and they're very good at what they do. And certainly any cyber range should be able to be used to train systems. The degree of flexibility that they have in representing your systems is a case that then says, well, how well are you going to be able to train your operators? If you're training operators for security information event management, incident handling, but you have to use an application, a SIEM tool, for example, that's not the same as what's in your operational center, then it is useful for training and equipping your operators generally in terms of security operations and incident handling, but not necessarily as much for your specific tools, your specific systems. The other two cases that we tend to focus on as well, which are less common in the cyber range marketplace, is the use as a lab environment and the use as a secure test and evaluation. As a lab environment, so this is very much for, let's say, security solutions that are in development, and they need a realistic set of scenarios in order to even have test data that they're going to use to develop and ensure that the solution is actually doing what it's supposed to be doing. And so in this case, the lab environment is used very much for research and development, experimentation, evaluating early prototypes, verifying the designs of those solutions in realistic emulation environments that involve both your OT and IT systems. So that's, let's say, on the security products vendor side, how the lab environment is used. But then in the same way that they use it for testing their tools, from a end user perspective, let's say in terms of the audience that's here today, you can use it for secure evaluation and test of new solutions that you might want to put into your environment. And so that could be a new security product that needs to be tested and evaluated in a larger system. It could be used as a pre-production environment for verification and validation of patches and upgrades that apply to your operational system. It could be used for a number of different pre-production needs that can help you to understand and evaluate and test new solutions, whether or not they're security related or not. And so you may actually consider that CyberRange can actually support non-security evaluation and test scenarios as well. Next slide. So what's the CyberRange structure? And so this is our particular structure. It's probably typical of most CyberRange that you would see. And so the user interface, and Paul will demonstrate the user interface in a few moments, but the user interface basically is through a web portal. And so that's what you see in the middle. There's going to be this access to an environment. What you see in the screen is a graphical image of the network that's represented by the CyberRange. But that graphical image actually then is connected to real operating assets operating in a virtual environment. Yes, not in an operational environment, but they are real operating assets that are interconnected according to the diagram that's shown. And so how is that done? Well, on the left, you see the digital and physical assets. So there's basically a digital library, a library of virtual machines that can be launched in the virtual environment and interconnected in various ways. The reason we highlight that digital and physical assets is that, as I mentioned earlier, in some cases, your operational systems, it's not practical for whatever reason to be able to emulate that in a virtual machine. And in fact, you need to interconnect with real hardware devices. And so our CyberRange has the option to do that in order to, from within that virtual environment, you can still interconnect out to real physical assets and back in, while still maintaining that safety of that envelope, let's say, that's created around the virtual scenario. Those digital and physical assets are interconnected according to an architecture, a diagram, an interconnection map that is represented in what we call the scenario library. So that scenario library represents how those assets get interconnected, but not only those assets, also any other assets that are necessary for the particular potentially malicious scenario that you're trying to test. And so if you want to do some penetration testing, you're going to add into that scenario certain resources that represent attack tools that an attacker may use to try and exploit the systems. And so the scenario library gives you that means to create not only the logical and architectural interconnection of your systems, but also systems that may be attacking your systems. It also encompasses, for example, a logical sequence. And so you can identify an attack sequence, an attack flow, and how that attack flow may be representing one scenario. You can clone that scenario to create another scenario with various variations and so forth, all of which that can then be initiated and started and reset and destroyed in a very dynamic way within the virtual domain of the CyberRange itself. Next slide, please. So a few different use cases that we have already achieved, and these are just a couple of examples, couple of cases where CITEF has been deployed. So one of them is at Ryerson University, and as part of the Rogers Cybersecure Catalyst. And so in this case, it's very much oriented towards training, but also to some extent towards experimentation and that R&D use case. So Ryerson chose RHEA as a partner for the Rogers Catalyst CyberRange for several reasons, mainly the flexibility of the platform. And so, as I was mentioning earlier, the pre-packaged training environments for Ryerson just wasn't a suitable response or a suitable approach for them. They want to be able to create their own scenarios and explore new training options and so forth. And so they needed something that allowed that flexible and adaptable means of creating new scenarios, being technology agnostic. And so if they want to use a different scene tool or use something else within the virtual scenario, they can do that. And access to existing scenarios, creating and adding new scenarios, and mix and match both IT and OT type assets on the same platform, along with that hardware in the loop, which is that interconnection to the external physical devices. So all of these are really features are really core of our CITEF solution, and that's a large basis of why Ryerson chose us. Next slide. So RHEA, you may be familiar with RHEA. RHEA are the power and water services company to the city of Rome. And we've been working with RHEA in various virtual environments since about 2013. So it goes back quite a few years now. And so it has to do with their use of, let's say, early versions or pre versions of what we have done with CITEF, but also still involved with us in CITEF. And so with RHEA, it's very much about being able to replicate a energy utilities scenario, including control systems, including high and medium voltage substations, including interconnections between them, including, for example, the SCADA servers and history servers and so forth. And so very much on the operations technology, also how those operations technologies may be interconnected with corporate systems. We can emulate, for example, the let's say the firewalling between the corporate environment and the operations environment, and how corporate environment may have to access the operations environment. And so within RHEA and leveraging on CITEF, we can do a lot of different use cases specifically for the energy sector. Next slide. Another operational technology use case for us, we're quite heavily involved with the European Space Agency, and we've been delivering a cyber range solution to them since about 2015. Most recently, we've been engaged as a prime contractor on the Security Cyber Center of Excellence project, and that project includes the delivery of an advanced synthetic environment. That's the term that they use. Effectively, their synthetic environment is a cyber range. It will be based on CITEF and will be used for the training services that we've been describing up to advanced levels, security test and vulnerability analysis, and also security operating procedures validation. So going beyond the case of training operators, it's also to be used for the use case where they emulate the operational systems and they want to actually trial and evaluate new operating procedures and to see how well those security operating procedures work in the face of various malicious scenarios. And so that will be part of the test and evaluation use case, but it's very much about the operational procedures. So the security test and vulnerability analysis is the test case for the technology, and then the security operating procedures is the test case for that operational side. Next slide. So at this point, we're moving from kind of the verbal description and background into the actual demonstration. Before we make that transition, are there any questions at this point?
Yeah, I have a question regarding.
Yeah, go ahead.
Yeah, the CITEF, does it come as a software, pre-packaged software, or it's an appliance that we get and install?
So it is delivered either as a service, meaning that we host the software and you can access it as a service. This may become more evident through the portal that Paul is going to demonstrate. So it can be accessed as a service, or it can be installed in your own data center as software. And so it can run fully only as software. The only hardware dependency is, let's say, some kind of a virtualization technology. So for example, VMware, OpenNebula, others So you need to be able to host the virtual machines and run the virtual machines. CITEF really sits as a software layer above that. So it would be at the software as a service layer above your infrastructure as a service, where you have the virtualization technologies. The only point where you become very dependent on the physical assets is in the case where some physical device may not be able to be emulated, and therefore you would want to interconnect a real physical system. I think there was another question that was just submitted by message. Yes. So a question around a ransomware attack on the virtualized SCADA systems in the simulated environment. So I think we'd have to talk about what you mean by a ransomware attack on SCADA machines. Generally, the ransomware is targeting towards something that's more user oriented, where data is packaged and encrypted, let's say, and you are being held to ransom to release that data. Now, if you're suggesting that the ransomware is actually packaging and encrypting and preventing you from accessing the SCADA server data, that's not a use case that we've directly employed yet, but it would be interesting to explore. I don't see any reason why we couldn't. So yeah, I would say certainly we can put the virtualized SCADA machines in there, and we can run various ransomware attacks in the simulated environment for sure. Other questions?
Great. Yeah, thanks so much, Doug. Are there any other questions regarding anything Doug just discussed? You know, what is the cyber range? What it can do for you? Some of the use cases with the, you know, RHEA and ESA. Yeah. Okay. If they do come up later, no problem. You know, feel free to you know, jump in or put it into chat. And I guess we'll pass the demonstration on to Paul. Thanks, Paul.
Thank you, Tim. Thank you, Doug. So I'm now gonna spend a few minutes showing you CITEF or Cyber Range platform that has been briefly described by Doug. So you have a better idea of what a Cyber Range looks like and how you can use it to meet NERC standards. I will start by showing you two images. So the first image you are showing right now is an image of a physical lab that was developed by CIMA Plus for a client. Of course, we have scrubbed it to make it more generalized, anonymous, but it will be a good example for the purpose of this demo. If you move to the next image, Tim, here is an image of the HMI controller that was used by this specific utility that we implemented within our Cyber Range. And the reason I'm showing you those two images is because this can be replicated inside the Cyber Range, inside CITEF. For your own use, of course, you will create your own CITEF environment that replicates your physical environment. That means the CITEF environment will run the exact same way as physical environment, meaning you can make changes, test those changes, monitor the environment. So remember, this is just an example simplified for the purpose of this demo, but it's totally configurable, and we will adapt it to your own environment and your own use cases. I will now share my screen to show you the CITEF interface. Okay, can you all see my web browser, my beautiful Chrome interface?
Yeah.
Yeah, thank you. So as Doug explained, the CITEF is an application that is running directly in your web browser. So it can run on any computer. You don't need resources like just a modern web browser, and then you can access the application. I'm gonna log in, quite simple. And then I'm gonna move to my scenario library and switch to my SCADA environment. So we didn't spend so much time on the images, but you may recognize on the physical lab from CIMA, we had a substation, which is represented here. Then you add your SCADA server to manage this substation, and then you have all your IT environment with your SOC team, a replica of the internet, your DMZ, your SCADA operators. So it really replicates your entire environment, both the OT side and the IT side.
So Paul, could you maybe explain what happens if a client's environment doesn't necessarily look exactly like this?
Exactly, a very good question, Sandy. So as I was explaining earlier, this is a simplified environment scrubbed for real-world client, but this is just simplified for the purpose of this demo. When we start working together, we will be able to customize this environment, this scenario, so that it matches exactly your IT and your OT environment. So for instance, I'm capable of adding a new network. Let me zoom in a little. The interface is drag and drop, so it's really easy to use. You don't need to be familiar with all the virtualization technology or all this complex architecture stuff. You just need to have an idea of what your network, your environment looks like, and then it will be easy for you to replicate it inside CITEF, or we also have services, professional services, if you need some help to replicate it. So here I added a new network, and then I'm going to add a new workstation. In that case, I want to add a specific IED that is running on my environment. So I will be looking in my library on the right. So we have normal IT asset, Windows, Linux, Kali, but we also have some IED. Here I'm using IED Scout. It's a tool which is used to emulate different IEDs. So for instance, the cell 451 in this scenario, which is used to control a breaker. Then I'm gonna, now this asset that I added to my environment is an IED, the exact same one that will be running in your own environment. So I'm gonna rename it to say it's my IED. Then as a next step, I can click on my network and configure some network details once again, so that it matches the network details in my environment. So I can configure the IPs, the subnet, everything. Another thing you may want to do is add an hybrid network. Once again, Doug talked to it a little before. The idea of an hybrid network is that sometimes you may not be capable of virtualizing your digital asset because maybe it's really old, so it cannot be virtualized, or maybe you want to connect the cyber range to a real element, to a real breaker, to a real substation to see how the system virtualized in your environment would impact a physical system. So this can be done directly from the cyber range. You just need to drag and drop an hybrid network and then connect a physical appliance, which is your physical device connected to the cyber range with a cable or the way you want to connect it, usually connected physically. And everything will be integrated from your web browser. You will be able to control at the same time your virtual environment, this safe environment, and your physical devices. So this is how you build your replica of your replica of your environment with virtual assets. And these assets function exactly like your physical assets. The only difference here is that you have contained the replica in a safe space where you and your team can test, reset, test changes to ensure you are meeting the NERC sleep standards that Doug will dig into a little later. Now is there any question at this stage before I switch to the live example to see your safe environment take live? Okay, if there is no question now, I will take questions at the end of the demonstration. So this was the interface to design your environment. Now we are gonna make this environment take live. So I will use the same one, but which is now running. The difference when your scenario is running is that you have now this little blue icon. And once you see this little blue icon, it means that you can click on it and then you log in to your environment. You log into your machines. So here is the machine of an attacker, but I can also log into my HMI, for instance, and then I can see the control of my environment. So remember, this is the exact same image that I was showing you previously. So in the CIMA lab, it was physical. We have a physical HMI with my HMI to monitor my single line in my substations to see the state of my breakers. So here, within the cyber range, you can recognize the exact same single line, the exact same HMI for my substation working. And you can see alerts at the bottom. Everything is working live. Within the cyber range, you have everything working exactly as in your real environment. It means like the exact same protocols like OPC UA, ISC 61850 GOES, for instance. Everything will be working exactly the same in your cyber range networks. Also, the exact same applications, your HMI, I just show you, your SCADA server, here is Ignition, will also be working exactly the same as in your real environment. And then your IUDs, in this case, the cell 451 to control your breakers. Everything works exactly the same way. The major difference with your real environment is that if you're running an attack in the cyber range, it's completely safe. It won't have any impact on your production systems because it's completely isolated. So you can monitor the impact, but it won't actually impact your production environment. And once again, remember that the scenario I'm showing now is inspired from a real client, but has been scrapped and generalized for the purpose of this demo. So when we start working together, it will be your own IT and OT environment which will be used. It will be your own IUDs, it will be your own connectivity platform, your own SCADA server, your own HMI, and even the IT part, it can be customized to exactly match your production environment. So now let's switch back to my HMI just to show you how it's working and that it's working live. So I have my single lines. You can see everything is open. My breakers are open here. So I'm gonna connect to my IUDs now. So remember, it's working the exact same way as your physical IUDs, but in this case, it's virtualized and contained within the cyber range. So you can see in my IUD, my cell 451, I have all my variables, monitoring over current, under voltage, and what I'm looking for right now is the state of my breaker. So I have it here, I have my circuit breaker. Okay, I select it. Then I go in my position, I can set the value. And now if I go back to my HMI, you can see that now my breaker is closed. So what happened here is when I modified the value in my IUD, it sent an ISC 61850 message to my connectivity platform, which was then translated into OPC UA, sent back to my Ignition SCADA server, and then monitor from my HMI. So you will recognize the exact same protocols and the exact same behaviors as in your production environment. Now, I will show you a type of attack that you could be simulating within a cyber range. So the document I just showed here is a document from NERC documenting the cyber attack on the utilities in Ukraine in 2015. So there is a lot of interesting information here. It was studied extensively by NERC. I can share the document with you if you want at the end of the presentation. But two interesting facts here is that they are talking of major threats to the utilities. They are saying that the one major entry points for the attacker are phishing attacks. So this is what we will be demonstrating in the demo, but you can also see ransomware. And I will explain to you how you could run a ransomware within your scenario. So we just saw that, so this is your environment, and your environment will be secured a minimum. You will probably have a firewall. And what a firewall is usually doing is preventing anyone from the outside of your perimeter, to get in your environment. So the attacker is stuck. He can try to attack a workstation in your network, but the firewall will block the attack. So a strategy the attacker can take, and we call it an entry point, and everything is described in the MITRE ATT&CK framework. The MITRE ATT&CK framework is a framework which describes the different categories and attacks an attacker can take, and we usually follow it in our scenarios. One thing it can do is start a reverse shell. A reverse shell is first using a phishing attack. You are sending a Trojan to someone within your company. And then when you open your phishing email and you click on the attachment, it will open a connection back to the attacker to give control to the attacker. And because the connection is starting from inside your environment, the firewall will allow it. So this is what we will be demonstrating now.
Sorry, Paul, just quickly, I think Fakhruddin has a question.
Yeah, please go.
Yeah, so it's regarding the images, so that we need to import to CITEF. Like, are those like regular VM images like OVAs and OVF, or it's different style of?
That standard image is OVA, OVF, so we can import. We have a digital library with already quite a lot of VMs available, both for IT and OT machines, but we can also import your own images if needed. It's really simple.
Okay. Another question, do you support non-Ethernet like devices? Can we add non-Ethernet based devices like that they have other type of interfaces, or this is only?
So you can add them, but through the hardware in the loop features with a specific connectors. To be able to run within the cyber range, it will, but like most of our recent protocols are encapsulated over Ethernet. Even like I will say the old SCADA protocols, now there is a version which can be encapsulated over Ethernet. So this is what we will be doing. From a testing point of view, from an attack point of view, it doesn't change anything, just it will be encapsulated over Ethernet.
Okay, thank you. So
really fast, I will be showing you the attack. So remember, I told you the attacker is waiting for the victim to open the attachment, the Trojan, so that it opens back the connection to himself. So I'm the attacker here. I connected to the machine of the attacker, and I'm now listening for the victim to connect back to me. So I will now connect back to the victim. Let me make it a little bigger so you can see like a phishing email. I make my victim believe that I'm the IT team and that he needs to open an attachment to update his VPN. As the victim, like the email comes from my IT team, so I trust it. Even if I get a message, like my IT team usually sends me messages with attachments that send me a message, but the IT team tells me like, don't worry, it's from me, so you can run it. So I run it anyway. Nothing happens. I think my VPN is updated. But now if I connect back as my attacker, I'm now connected to my victim. So to demonstrate that, I'm able to take screenshot of my victim screen. I could also monitor what he's doing, gather his credentials. Like if we are an attacker with using an APT kind of attacks, he will try to stay a long time on the victim's machine, trying to understand how the HMI works, how the networks works, so that he can do small changes on your network and you won't be able to notice that something has changed. So this is the kind of attack and the kind of simulation you can run inside the cyber range. Any question here?
Yeah, one question, Paul, is do you simulate those attacks like denial of service attack in such an environment?
Yeah, all these kind of attacks, we can simulate them, ransomware, phishing, denial of service. The only thing with denial of service is, of course, you are virtualizing everything. So if you want to test the capacity of a physical server, you will use the hardware envelope features to put your real hardware, because usually denial of service really depends on your hardware capacity to handle a request. So for this one, you will use hardware envelope features. But for phishing, for ransomware, to test like vulnerabilities in your applications, all of those kind of attacks can be tested directly within the cyber range. And to give you a couple of use cases of like current clients and organizations use CITEF 2. One main use case is to test their systems and understand how they behave under attack or within abnormal conditions. So for instance, some of our clients prefer to run penetration testing and vulnerability assessment in the safe environment of a cyber range to make sure it will not impact operations. Otherwise, quite often you need to limit the scope of your penetration testing to be sure it won't impact operations. Some other organizations train their operators to be more efficient under an attack. So some of our clients train their SCADA operators, overtrain their security team, or even all their employees to see how they behave under phishing. Some clients also run their tabletop exercises on CITEF so that employees can practice the organization's security playbooks. And last but not least, some organizations implement new architectures and tools on the cyber range. For instance, before choosing to implement a new architecture or a new tool in production, our clients usually want to try different options to test which performs the best and find any integration issues. So with CITEF, you can run different scenarios in parallel, each with different configuration, and then you can compare the results and choose which is the configuration, which is the software, the tool that works best for your organizations and for your environment. Any questions on those use cases? If there are no additional questions, now I will leave Doug, who will speak again about the specificities of the NERC SIP standards and how this can be met using a cyber range platform.
Thanks, Paul. I think the demonstration was great, and you know, if our clients are interested, I'm sure we can arrange a more personalized demonstration that might be more applicable to your environment and the things that you would like to test. So, but we can definitely talk about that after this. So I'm going to share back my screen again and pass it on to Doug to talk about NERC SIP compliance.
Thanks, Tim. Thanks, Paul. Yeah, and even just touching back on the earlier question about ransomware against the SCADA server. So obviously, you know, Paul was using a phishing attack here, and that's the precursor to a ransomware attack. And so, as I said, certainly we can emulate ransomware attacks. That specificity of having the ransomware attack against the SCADA server. In this case, it was against a user, an operator with an email. How then perhaps the attacker would embed a Trojan that could in some way encapsulate the SCADA server, or maybe get an escalation of privilege and a user access. As Paul mentioned, you can record what's going on the victim system, and so then you could get the user access to the SCADA server. And if you get the user access to the SCADA server, then what you can do to encapsulate the data on the SCADA server, all of those would be aspects of a scenario that could be tailored for your particular needs. So touching now on the SIP standards. And so I want to make it clear that CITEF, cyber range in general, is not going to, it's in and of itself, let's say, be used to prove your compliance. What it is really is a tool that is used to perform the activities that are required to demonstrate your compliance. And so what I mean by that is, for example, as we'll see in a couple of slides, one of the requirements is to perform cybersecurity related training. Well, by having CITEF as a tool, you have a non-production environment which can help you perform that activity of conducting your training. The compliance to the standard is still demonstrated by the fact that you have to run the training, you have to have training results, and so forth, and the scope and scale of your training. CITEF becomes a tool to help you do that. And so hopefully that, keep that in mind as an overall concept. Next slide, please. Tim? Yeah, thanks. So, right, the CITEF, as has been demonstrated, it's this flexible on-demand environment that lets you use your digital and physical assets library to build a scenario, a simulation that emulates your environment in this virtual lab, which should simplify the process of ensuring compliance. And the next couple of slides give some highlight points of how you can do that. Next slide. So in the next two slides, we've got a whole series of examples that come directly from the NERC-CIP standards and what the NERC-CIP standards requirements are, and then how, by comparison, CITEF can help you do that. And I'm not going to go through each and every one of these in detail. I'd basically be reading a slide to you. I'm going to talk in more general terms. I'll cover a couple of them directly, maybe, but certainly these slides will be provided to all of you at the end of the presentation, and you'll be able to go through and see in detail. And certainly if there are any of these that trigger your interest and you want to have discussions about them, about how CITEF can help facilitate that process of achieving compliance and how it can be used as a tool to get there, absolutely, we'd love to engage with you in some conversation. Assessments. And so the NERC-CIP 010-2 mandates a collection of process and technical requirements related to configuration changes and vulnerability assessments. Basically, when you're making a configuration change, you need to understand the vulnerability of what that change is going to, and how that change could affect your systems. And without having a separate non-production environment like CITEF, then your option is really analytical, which has its place certainly in the the demonstration of how to meet this compliance point, or you have to somehow manage to have a test environment, which already starts to suggest something like CITEF. Otherwise, you'd have to actually implement the change and then do a vulnerability assessment on the implemented change. In our experience, access to a pre-production testing environment, sometimes that's true, sometimes that's available. Usually where it's available in a very limited scale and scope, meaning certain systems are available in a test environment, but to be able to understand the vulnerability impact and to do a proper vulnerability assessment, it should really be in the context of your end-to-end environment. As we've just demonstrated, the CITEF allows you then to check for vulnerabilities based on connectivity access from, in this case, it was from the internet. It could be an insider that's represented in the scenario. It could be any number of different start points for those scenarios. The point being that the vulnerability is then assessed in a very strong emulation environment, which replicates your operational systems as closely as possible, giving you the best possible vulnerability assessment for the understanding of that configuration change and whether or not that configuration change is going to be helpful or in fact a hindrance. You have, for example, there's plenty of examples where a patch update causes systems to fail. Certainly you don't want to go through a patch update on your operational systems and with the potential to have them fail without first some kind of a assessment of whether or not that patch update is going to cause a problem in a non-production environment. And so CITEF provides you with that non-production environment in which you can get a much better representation, a much better understanding of what the real vulnerabilities of any configuration change might lead to. Second one here, cybersecurity for personnel and training. I briefly introduced that a couple of slides ago, but basically your training in a operational environment is very often limited by operational needs. And so you can do, let's say, tabletop exercises, you can do some level of training, but generally you're not able to access the operational systems. And so the alternative in many cases is to run kind of theoretical training, right, in which you are given perhaps classroom instruction with a series of slides and information that's contained on the slide, which is all very good, but it doesn't give you the hands-on reality of what's going to happen in a particular situation. And so your training is that much better, that much more improved if you can actually have a hands-on environment in which these scenarios can be run. Studies certainly have shown within any educational environment, what I see, what I hear, I retain a certain percentage, but I retain much more from a knowledge basis, and much more training success comes out of having the situations where I'm actually involved, where I actually have to do something. And so that hands-on capability that the cyber range allows, which you can't do on your operational systems, really enhances the training. Now, can you achieve compliance with the existing training that's very theoretical? Probably yes, because to some extent, maybe that's the best you can do. And so you're performing training, but can it be improved? Can it be better? And so it almost becomes a case of, okay, is this really, are we trying to just achieve compliance? I shouldn't necessarily say just, because a lot of the demands are quite onerous, but am I doing that training to achieve compliance, or am I doing that training to really improve the security of my environment and improve the cybersecurity capabilities of my staff? And you'll achieve much more, much stronger, much higher levels of outcomes when you can actually use an environment in which you actually really provide that hands-on capability. Cybersecurity electronic perimeters. The CIP 005-5 talks about the understanding of your requirements on applicable entities to establish protective controls at the perimeter. And so again, you can implement your architecture, and you can understand your architecture, and you can implement those electronic security perimeters, but how effective are they? That comes down to the evaluation and test of those systems, and a cyber range really allows you, hopefully as has been seen by the demo, to really emulate and test those perimeter controls, to use that then as evidence to say, not only do we have the perimeter controls in place, here is, from a testing perspective, how effective they are. And when you do that in the context of a cyber range, you're getting a much closer correlation between the test environment and the operational systems. I think I'll stop there in terms of the specific NERC-CIP examples. We can pass to the next slide, and you'll see that there's a number of other cases that we've identified where the requirements of NERC-CIP compliance can be helped by having access to this kind of a non-production environment, but a non-production environment that is really closely aligned with the emulation specific to your environment. And on that, I'll take questions, and I see there's a question in the chat. Let's have a look at that. Oh, yeah, absolutely. So the question is there, even though Cyber Range is customized for OT environments, can we use this for vanilla IT environments as well? Yes, absolutely. When we say it's customized or tailored for OT environments, coming back to Paul's comment, those scenarios are completely, the CITEF itself is just a host. It's a host environment for virtualization of really anything that can be digitized and virtualized, or in fact, with the hybrid case, as well your physical systems. And so we happen to specialize in OT scenarios because that happens to be a niche area, particularly with CIMA Plus, that we kind of focus on. But absolutely, we can emulate the IT environments as well and use it for testing your perimeter systems and even your non-perimeter systems, your internal systems, test for insider use cases on your enterprise, for example. All of that is fully possible with the CyberRange.
Thanks, Doug. I guess, yeah, we can definitely open up the floor to any questions about anything that we presented here. Maybe a couple of quick ones that, we have, kind of that would typically get asked, how complete is the existing digital assets library? It is possible to, insert other equipment in there that may not necessarily exist.
Yeah, absolutely. And maybe I'll let Paul answer more directly about how complete the existing library is, but absolutely the library can be expanded as well.
Yeah, so we have several hundreds of assets. We have lots of generic IT assets like workstation, Windows, Linux, firewall, SIEM systems. For VOT, we have a few in different categories. Of course, it's impossible to be exhaustive because there are so many IUDs, so many elements on the market. But you have a possibility, as we explained earlier, to come directly with your own image, virtualized image, and add it to the library so that the digital library is customized for your own organization.
Thanks, Paul. And what about interconnecting with physical devices? Is that a possibility from the virtual environment that the emulation is in?
So it was part of a demonstration. Remember how we had these physical devices that you could plug directly from the drag and drop interface. So you plug your physical device to the CyberRange, and then it can be controlled directly from the CITEF interface as if it was virtualized. So it's really easy to do that with the platform.
Okay, sorry, I missed that part. Okay. Yeah. Any other questions from anyone else? I know Fakhruddin, you had quite a few, or Franck, or Jean-Francois, Craig.
Yeah, I have a question regarding the pen testing tools that are readily available. What are those tools that you have?
Yes, so we do not commercialize any pen testing tools ourselves. So we are professional services. We provide professional services for pen testing. So our pen testers have their own tools where they are using and that are available within the platform. I'm not an expert pen testers. I think we have Nessus and this kind of tools for vulnerability assessment and pen testing. And we have also, of course, Metasploit, all those frameworks. But any like if you want more information, we could put you in contact with your pen testers, and any tools you are using internally can be also included within the CyberRange platform. So really, the CyberRange platform is a tool to test your environment in a safe and legal place where it won't impact your production system. The way you do your penetration testing is like similar to how you will do it if it was running on your production environment.
Thank
Yeah,
you.
maybe I can just emphasize that point. As I mentioned earlier, and sorry, I seem to be having some issues with my video at the moment. Otherwise, I'd put my video on. But as I was saying earlier, CITEF really is a host environment, and as a host environment, the goal is really to emulate your systems and your operations as closely as possible. And so if you have particular procedures that you're using, if you have particular tools that you're using in order to conduct your security testing, you can absolutely use those within CITEF itself. It's not that CITEF is going to prescribe directly the tools that you must use to conduct your testing. We have several that are available, and so generally the digital library can host any number of open source tools. But if you have something specific that you would like to include, absolutely, it can be incorporated.
Does it answer your question, Dr. Dean?
Yeah, thank you.
No problem. Any other questions? Was this interesting at all?
I do see that Matthew is typing something.
Okay.
Yes, I was actually, I could just say it. I was just saying if there are any follow-up questions, I mean, everybody just feel free to reach out to me and I'll direct the question to the right person after the meeting.
Yeah, I think it looks like Craig is wondering when the recording is going to be available. So Mathieu, I'll field that.
Yes, so the recording we'll make it available, in the next few days. We can send it to you guys with the presentation. Again, if you want us to do another presentation with your team, we'll be more than happy to do it. So we'll send you the deck and the recording. And if you'd like to arrange for something a little bit deeper, just let us know. And we'll arrange that for you.
Thanks, Mathieu. Yeah, I think we can certainly. I mean, we plan on following up with each of you to see if this was interesting for you, and if it was, if there's maybe some further demonstrations, just like Mathieu said, that we might be able to perform. But yeah, either way, we will reach out and you can let us know if there's anything in particular you wanted to see. I guess I'll just open up one more time for questions if there aren't.
I just want to say, Tim, sorry, it's me again. I know that I think only one person opened the gift card that we sent you guys for lunch. So hopefully you got this. If you didn't get it, it may be in your spam folder, or let us know if it's not. But we sent you the little Uber card. So hopefully you received it.
Yeah, and if there are any issues with that, just fire us a note and we'll make sure it's taken care of. Okay. All right. Well, if there's anything else, or if you can't think of anything right now, but it comes up later, don't hesitate to reach out to either myself or anyone on the RHEA team. It's been a real pleasure performing this webinar for you guys, and hopefully you found it useful and interesting. And thanks again for all of your time, and we'll catch up with you on the next one.
Thank you all very much.
Thank you all.
Thank you.
Thank you so much.
I just see that we have Jean-Francois is writing. Oh. Oh, there we go.
No problem, Jean-Francois.
Yeah, thanks for the presentation. A little bit above my head for the second part. I missed the first part, but I'll watch the replay.
Yeah, as Mathieu mentioned, we'll send the replay and the slides in PDF, and I think Paul will probably send that PDF from NERC study on Ukraine to you guys, and you can digest that, and we'll follow up with you and see if there's anything else we can do for you.
Thank you.
Right.
Have a good day.
Thank you, Jean-Francois. You take care.
Thank you very much.
All right. Thanks, guys.
Stop recording, or?
Yeah, stop recording. Or you have things to say that